Hello, everyone, and welcome to Rational Science, directly from Frankfurt, Germany. We have a busy day today, and so I'm going to get right to it. We divide our show in three parts. The first part, we deal with extinction. Second part, we're going to be dealing with physics. Today is spin. We all know what spin is. You take a top, you spin it, no problem, piece of cake. And then after that, we're going to do some of the try to answer some of the questions and comments that people made. Okay, let's get right to it. I've held that if the United States government happens to fall, by that I mean, the economy happens to collapse, to disappear, to disintegrate, that's the end of it for the world, because the United States is the American empire is so big, it's got its tentacles everywhere. It's too big to fail. Okay, so we all would do well in propping up the United States government, especially that one, because it's the biggest government on earth. Okay, and so the question for you today, I've got a couple questions. That's the first one. It's going to be, is the United States government collapsing? Is it disintegrating? Is it imploding, losing ground? And you see some of the problems that you hear out there. One of them is U.S. protests. There's riots quite often lately. Okay, they're pulling out of Afghanistan. Assessment says that maybe in about 6 months, the Taliban are back in power after so many years, 20 years of fighting. Then we have the problem with Iran, Saudi Arabia, and Israel. That's an ongoing one. We have big problems in Haiti, Honduras, Guatemala, and the Caribbean. Tied to that, Cuba also starting to have riots. Communist country with riots. Can you believe that? North Korea, they don't have riots, they have starvation, unless the Chinese feed them. Then we have South America, Brazil, Colombia, Argentina, Peru, all with major problems. A lot of it brought about by the draconian measures taken by the governments because of this COVID stuff. Okay, but they're all suffering. Lots of people who are out of work, especially in the tourist industry. That's what happened to Cuba, by the way. Tourism stopped. Tourism became an important part of the Cuban economy, and then suddenly it collapsed. So yeah, it's a big problem for the Cubans. Chinese, on the other hand, seem to be doing pretty good. Yeah, they're expanding into Africa, especially, also in other regions, at the cost of the United States. Okay. Then you have Russia-China pact. They've got a couple economic and military pacts out there, treaties and so on. You have Brexit, happened just a little while ago. Is this the beginning of the breakup of the European Union? At the bottom you see that's a riot in Indonesia. Today you had another one, or the numbers came out for South Africa. There's riots everywhere. And you better get used to them, because riots are going to be very popular. People going out in the streets and protesting. Is something going on? Is something unusual going on? A lot of people might say, well, there's always been problems, problem between countries, within countries, and so on. I think this is a little different, what we're seeing now. Okay, I think what we're staring at or hearing out there is a little different than what's happened in the past. I'll tell you why. Big problem that we have today is that we're not expanding. Our population is stagnating, and because of all these problems, the corporations are now going to be, apparently they're going to be taxed at a higher rate. Okay. And here you see there's news came out. Global tax reform plan goes to the G20. Okay, and the G20 and other countries as well, they decided to tax the corporations at a higher rate. And part of the reason is that, a lot of people have lost their jobs, and there's not much you can tax from someone who's receiving welfare. And so what happens is, the governments have to get the money somewhere else. And so they want to tax the corporations. Instead of 12%, they want to jack it up to 15%. Apparently, a lot of countries are in agreement with that, except a couple, like, Ireland, for example. They don't like that idea because they entice companies such as Google, Apple, and Facebook to install their headquarters in Ireland in exchange for giving them good tax breaks. And now the European Union and other countries are saying, well, you got to tax them a little higher because we all have to be more or less at the same level. And there are some countries that just don't like that because they're receiving the benefits today of low taxes and so on. So, one of the issues you got to think about is whether it's a good deal to tax major corporations. Okay, but what is the problem? As I see it, this is the problem. And here's a map that puts it on the map. Okay, these are the cities of the world, the big cities of the world, more or less how population is distributed. And I've circled regions, major regions on the planet where there's few people, almost no people, maybe a village here or there. These regions are empty. You could almost say there are more empty regions than filled regions on the planet. Okay, what's the problem? Well, the problem is that everybody is moving to the cities. We have not created new cities in the last 100 years in any significant way. What we've done is people have moved from the country to some cities, made them big, made others even bigger. But what we're doing is abandoning the countryside to the big corporations that do agriculture, and we're not founding new cities in, new villages, new towns in those empty regions. And the question is, are we ever going to do that? Is this ever going to happen? Are we going to fill those regions that I've circled there? Or are we ever going to create new cities? And I don't think so. How would a government create a new city? Just force people, with a gun and take them out there to the fields and say, you're going to have to live here from now on. Is that the way it's done? And even if they do that, the question is whether they're going to, have children, which is another issue. And here you see some of the numbers for some of the big countries to see what's going on. This is the big picture, okay? Here's Russia. Population decline more than doubles in 2020. One article that I saw over there. Russian population decline more than doubled in 2020. Okay, Russia's population total 146 million as of January so-and-so, down from 146.75. They lost 700,000 people last year. And Japan population fell by 868,000 in 5 years. Over 5 years, 2020 census shows. The United States, what the 2020 census will reveal about America's stagnating growth and aging population and youthful diversity. And recently released Census Bureau population estimates show that from July 1, 2019 to July 1, 2020, 1 year, right, the nation grew by just 0.35%. This is the lowest annual growth rate since at least 1900. We're not having children, and part of the reason is we're not creating cities, and part of the reason is that everybody from the country is moving to existing cities and making them, these megalopolis, gigantic monster cities, antholes, as I call them. And here's Europe, okay, just so you can see the numbers. How to tackle population decline in Europe's regions, one article, okay. Rural area make up to 44% of the EU's surface, but 78% of the European population lives in urban areas or functional urban areas. How about Africa? Well, it's the only continent that seems to be growing. Africa population will triple by the end of the century, even as the rest of the world shrinks. It says Africa will be the only region in the world where population will still be growing at the end of the century. Given a 48% population decline expected where? In China. Yeah, believe it or not, China is going to go down according to the estimates. And it says Nigeria will become the second biggest country by 2100. And it goes in there and says by 2100, up to 183 countries will have fertility rates lower than 2.1 births per woman, which is what's considered as the replacement rate. Okay, so this is the situation. And so the question is whether there's any chance whatsoever of us ever expanding again. You know, if you go back to the 14th century, mid-century, there was apparently the bubonic plague, killed anywhere from 1/3 to half of the population of Europe. And after that, we got rid of the rats, the fleas, right? And population started growing back again. Why? Because it was a young population. Disease kept us down. When it wasn't the the bubonic plague, it was maybe smallpox or the childhood diseases, you know, rubiola and one of those. And it would kill a lot of the kids, and it would also kill the endemic disease. It would still kill lots of older people. And so the population was kept young by disease during centuries. And after the 19th century, well, you know, we got used to a lot of these diseases, especially when we went into the cities. You know, we had lots of people in a given place. Lots of people would die when cholera or some other disease attacked. But then after that, we got used to a lot of diseases. We also invented vaccines for those who believe that vaccines help us out with immunity and so on. But the issue is that today we don't have any childhood diseases. They don't kill nearly as many as they would kill at the beginning of the 19th century. In the 1800s, half of the children under the age of 5 would die because of childhood diseases. They had no defenses. Today, we are the descendants of those who lived and procreated and gave us their defenses to us. To most of the population. There are people still out there that have no defenses, but in general, the population has been immunized. So we don't die of diseases today. We die of old age diseases such as heart ailments, diabetes, you know, arthritis. Like in my case, I have arthritis. So, you know, we die of different type of diseases, and they have to do maybe with genetically how we're genetically structured. You know, at some point you got to die because you can't live forever. And so genetics, you know, sets in. So what's happening is the following. This is what the population of the Earth is looking like, okay? The pyramid is inverting, okay? The question is how fast it's going to invert. That it is inverting and that we cannot do anything about it. I think nobody can say anything about that. Okay, I'll challenge anyone who says that we can do something about it. No, we can't. Women can no longer, not women, but women, plural. Women cannot do anything about procreation anymore. Okay, we're done with procreation. Once you come to the cities, there is no possibility of having children again. Okay, so is Africa going to triple by the end of the century? Absolutely not. Because even in Nigeria, the countries that's growing so big, so fast today, everybody's going to be moving to big cities, to Lagos and, you know, the main centers. They're going to move from the country to the city. That transition is going on right now. It's going to accelerate later on as much as it can. And once the people get into the cities, the women will not have children. The couples will not have children. They might have 1 or 2. They're not going to have 8 or 10 anymore. That era is going to be gone. So no, there's no way Nigeria is going to triple, for example, its population by the end of the century. Never going to happen. And again, it's the transition that's going to kill birthing. Once we're in the cities, no children. Okay, so yeah, what can I say? You can see the population decline as the growth rate there. By maybe mid-century, we're going to be growing at zero population growth, as it's called. There's going to be no growth of population on Earth. We're not creating cities. The big countries, the important countries, are no longer having children. In fact, a lot of them are already in negative growth. Here in Europe, Spain, Italy, they're already in negative growth. And so if the important countries of the world, part of that G20, okay, if they're not going to have children, are they going to live out of immigration, just allow people from other countries to invade them and do maybe the menial work at the beginning and then rise up and change the composition of society. No, I don't think that's going to happen. There's going to be immigration. There is immigration, a trickle right now. I don't think we're going to evacuate Nigeria by bringing all those people here to Europe. Okay? So the big problem, we're not creating cities. We don't create cities. We're not going to expand our population. We die with the existing cities. I don't think Russia will create a city in Siberia just to populate the country. I don't think Argentina is going to populate the Pampas, form a city over there. It's never going to happen. Whatever cities you see on the world today, that's how the world is going to end, with those cities. They're just going to be filled with more people. Okay? That's my take on that. Okay, second question today is not necessarily related, but it's related to the economy, and that's what I'm referring to when I say, is the United States government going to collapse? Are its colonies, extra-official colonies? They're all colonies, but you don't want to call them that because it's not a very good name. The United States has a lot of influence over those countries, economic influence especially, right? And they have to bow down to a lot of the demands that the United States has because they do commerce with the United States, and the United States otherwise takes revenge. Okay, so it's all the same empire. Okay, so the question is that empire receding now? And if it recedes, if you don't grow, you die. So if the United States is receding economically, at least, maybe not militarily, but economically, can it continue to recede until what? Until it collapses? Or will there be a war and we get back to normal human behavior? Okay. Yeah, there could be a war, but if there is a war, it's an economic issue. So it always comes down to economics. Okay, and here's another related issue to economics. We have crypto crime today. New type of crime. Jesse James would rob banks and trains, especially trains. Bonnie and Clyde, they'd rob banks. Those are the good old days. Nobody robs banks anymore. I don't think. Well, some people do, but it's a lot easier to catch them, and it's not as glorious as it used to be. Like, it's an anachronism if you go and rob a bank. No, you do it the modern way. You do crypto scamming, okay? And they found a crypto mining farm in the Ukraine, 3,800 PlayStations and 5,000 computers. You see a picture there. The guy had all these computers there to do crypto mining, okay? So pretty soon it's going to be big business to get into this crypto crime world, and a lot of people, just like people get into buying cryptocurrency, a lot of people are going to get into crypto crime because it's harder to detect. It's no longer chasing across the state line behind Dillinger or Bonnie and Clyde. No, now you've got a different situation. You got these anonymous people out there, and they are using computers to attack the system, and you can't always find them so easy. In fact, there's several crimes lately where companies have been forced to pay ransom to get their data back in the United States. The United States accuses Russians and so on. Yeah, so crypto crime is on the rise. And here's another crypto news. Crypto scammer sentenced to 15 years in prison. Swedish, a guy from the European Union, an educated guy, a person who was educated also to respect the law and so on. Swedish citizen Roger Nils Jonas Carlson defrauded thousands of victims and stole tens of millions of dollars over a period that lasted almost a decade. Sentenced to 15 years in prison, or to pay his victims $16 million, etc. And he did it all through crypto accounts. They caught him in Indonesia and asked for his extradition. So crypto crime is on the rise and will continue to be on the rise because it's considered by many programmers and so on that they can get away with the crime, that they won't be caught. So get ready for that. That's another thing. And the question is, uh, we've come a long ways from the days of biblical Ruth, being paid with barley. We're no longer in those days. Today, we have cryptocurrency, this abstraction that governs the world, or that is slowly gaining ground on the traditional coins, fiat money, and so on. Is that going to break the World Bank? Yeah, the piggy bank, the treasury of the world. The fact that we have all this coinage out there that, at least so far, is not regulated. Think about it. Is this out of hand, this cryptocurrency? Should it be regulated, or should we let the market system govern, and those who commit crimes go to prison if they're caught? Okay, so think about that. Okay, going to the Neanderthals, fellow asks or says, Neanderthal rape never happened. Humans have been known to stick it in all sorts. No doubt there is doubt. Your assumption that Neans and Dinos, Denosivans, I got it wrong, I'll get it right in a second, were entirely different species, respectful of proto-human femmes honor is a little presumptuous. No, it's not a question of being of them respecting the honor or anything like that. What we're talking about is two different species. Neanderthals were a different species. And so the question for you is, do lions do it with tigers? Assuming you let go of a tiger in lion territory, or lion and tiger territory, whichever way. Do you think the lion will mate with a female out there, or vice versa? No, believe me, they'll attack that other species and kill it, even though there are ligons and ligons and not tigers, tyons. The mixture of lions and tigers. We have them in the zoos, under control of man. Out there in the wild, doesn't happen. Okay, you don't have that in the wild. Okay, you might find, I don't know, maybe some exception out there. It's not the norm. Okay, to say that Neanderthals would sleep with women, and human woman, or a man like this guy running away from the Neanderthal gal, no, I don't think so. And then again, one night stand does not produce the disappearance of a species. In order for there to be a disappearance of a species, if every member of the Neanderthals at some point had to have sex, reproductive sex with humans. It can't be just a group, because if the other group continues to have sex among themselves, within the species, then we should see Neanderthals alive today. If we don't see them, it's because every last Neanderthal who procreated would have had to have sex with a human species. And good luck with that one if you think that ever happened. No, absolutely not. And that's why the admixture theory is bunk. It's absolute bunk. It's only put forth by geneticists because they created a cottage industry for themselves. They are the rulers now of Neanderthal extinction. They tell you what to believe. They say, yeah, we proved it. We got 2% Neanderthal DNA. Yeah, I mean, we had a common ancestor 800,000 years or so ago. No wonder. Yeah. Does that mean that they had 40,000, 45,000 years ago? I don't think so. Not in the wild. Not when Neanderthals were the worst enemies of a Neanderthal. Humans were the worst enemies of humans. And if a human, clan walked into Neanderthal territory, I'm sure the Neanderthals would have liquidated them entirely, maybe eaten them, thinking they're some kind of animal, another animal to hunt. Okay, so no, I don't think it ever happened. Okay, along the same lines, fellow says there are people who propose a fundamentally different theory. Europeans are in fact Neanderthals with a little bit of admixture from Homo sapiens Africans. In other words, humans came into Europe to enrich the already morphing Europeans. And you go to that site, the site that he mentions, differences between Neanderthal skeleton and the so-called modern humans are certain. Yeah, there are many differences between them. And more than anybody, especially in genetics, these geneticists are willing to admit. They say, yeah, we were different, but we had sex. That's like a weird kind of theory. If we're so different that you can tell the difference even today, 40,000 years later, just by looking at their skeletons, they must have been quite different in real life, quite different. But what did we do? Well, Neanderthal this century, 20th century especially, right, suffered a tremendous evolution, the biggest evolution I've ever seen in any animal species. Here you see it at the beginning of the century. Marcelin Boulay, French guy, he made this picture of Neanderthal, what he thought the Neanderthal looked like, the one on the left, and he looks more or less like a gorilla. And there's the skeleton he got that idea from. He worked together with a paleontologist. And from that skeleton, from that, well, obviously that's already built up, but that's what the guy apparently looked like when you put a little skin over him. But from the skull itself, this is what Boulay came up with. On the other hand, today we have this lady, Elizabeth Daines, and she's a French lady, and what she does is she tries to, reproduce, reconstruct faces and bodies of old Neanderthals. And this is what she came up with for the same skeleton. She also looked at that skeleton. She came up with this guy on the right, and he's a little bit different than the guy on the left. Okay, among them the hair and a lot of things that are kind of hidden, like behind the beard and the whiskers and so on. So the question is, did Neanderthals look like the guy on the left or like the guy on the right? Who is right? And yeah, if you look at some of the pictures we see today of Neanderthals, in fact, all of them, you can see they look pretty much like humans. Okay, they've humanized them over time. And this is not what you would have found at the beginning of the 20th century. The question is whether this is the right notion of what the Neanderthals look like. Another thing that they do is they clothe Neanderthals when it's absolutely clear that Neanderthals could never have used clothes. Okay, there are no needles, as I explained the other day, and we found obviously no clothes, and I don't think you'll ever find any. You won't find any boots. And the needle, I mean, with all the sites they found from Neanderthals, they found all kinds of tools and weapons. Never have they found a needle. Short or long, fat or skinny, they've never found a needle. And that is strange. You would think that at least one needle would have survived out of so many sites. That's not the case. And so again, Neanderthal had no reason to dress up, but we always dress them up. I guess the actors don't want to be nude on the screen or something. And yeah, this is what you'll see out there. And so what they've done is they made the Neanderthals look like us in great measure, and the more we go into the future, the more they'll look like us, because they're trying to push this interbreeding theory, the admixture theory. That's the only reason for that. Okay. Another fellow brings up the issue. He says the out of Africa theory has been debunked decades ago. And out of Africa, for those of you who are not familiar, is that humans essentially were born originally in Africa. They migrated far east, all the way to China and also to Europe, where we allegedly met the Neanderthals. Okay, this is the theory today, and this fellow is criticizing the out of Africa theory. Well, it's not debunked. Debunked for whom? For you. Okay, unless the proposal is irrational, then you cannot say it's debunked. Irrational. You can say it's irrational, yeah, if it is irrational. Otherwise, there is no such thing as debunking in science. We might use that word informally, but debunk means that you don't believe in a theory. Okay, so it's either irrational, it doesn't belong in science in the first place. If it's rational, the assumption is rational, well, then it can be incorporated into science and you can build upon that. And so we do have a criterion or a set of criteria for what is rational, okay? And the main one I want to put to you out is that third one. It says theory is inconsistent with or doesn't follow from the assumptions. That would be considered irrational. And so as long as the theory here, follows more or less the assumption, then there is no problem. Then there should be no complaint as far as, or calling it debunked. Debunk only means that you don't agree with it, okay? Okay, let's continue here. Another issue related to extinction. Are we going to leave the planet? Are we going to have be a spacefaring civilization? Are we going to build ships and orbit the Earth? Are we going to go to Mars? Are we going to go to the moon? Or who knows? Well, some people are proposing going to Venus. Let's terraform Venus. They say it's a better candidate than Mars. It's closer. It's closer to the sun also. That's good. You get heat instead of cold out there way in far away in Mars. It's got CO2 just like Mars, but CO2 here in Venus a little more dense. In fact, quite a bit more dense. It would crush you if you were on the surface of Mars. That's how dense the atmosphere is. We would not be able to resist it. Okay, it's also a lot hotter. I think like 450 degrees centigrade. And they say, okay, but it's got its advantages. It's got almost the same size as Earth, the same mass. That means we don't have to worry about gravity like we would have in the case of Mars. Mars is, like anywhere from a quarter to a third of the Earth in mass. It's a small planet, and so it doesn't have the gravity that we have here on Earth. So that would be a problem forever. The other one is that, it's got a very light CO2 atmosphere. And so you would need to turn that into oxygen, but then again, the gravity would not be there to hold that air. And second, the pressure would not be the same as here on Earth. So there are several problems with Mars. A lot better candidate is Venus. The only problem with Venus is to terraform it, like they suggest there, turning it into what it is today to what it should be in the future. It's going to take like 200, 300,000 years, at least with the technology we have today, with the notion that we have of how to convert chemically, one atmosphere into another, CO2 into O2, for example. Okay, so that would take 200, 300,000 years. I'm not even sure we're going to get past the next 30 years, so I think you should forget about that. But it's for people who do a lot of Star Trek and very little real scientific study. They're into technology, not into science, into trying to figure out whether it even is within the laws of probability, that we're going to go to any of these planets or the moon, okay, or in orbiting satellites of some kind, spaceships. Never going to happen. Maybe for tourism, yeah. And talking about tourism, we had this week also another guy that spaced out, and this guy is a billionaire entrepreneur and adventurer. Richard Branson's dream of space travel was realized, and celestial tourism took a leap forward Sunday as Virgin Galactic's rocket ship reached the edge of space during a historic flight from Spaceport America. And turns out he's a billionaire there, okay? And it says, okay, he went up into space, he was floating out there, he was all excited, okay? And there was a comment from Senator Bernie Sanders. And he said the following, he said, Vermont Senator Bernie Sanders was less impressed. Here on Earth, in the richest country on the planet, half our people live paycheck to paycheck. People are struggling to feed themselves, struggling to see a doctor. But hey, the richest guys in the world are off in outer space. Yes, it's time to tax the billionaires. Should we tax the billionaires? Should we tax the big corporations? Like I started the talk today. Is that what's going to solve it? Take the money from the rich and give it to the poor, little Robin Hood kind of stuff? Or should we allow the money to stay in the hands of those who are wise entrepreneurs? Yeah, they have a little fun on the side, like going into space, but they're going to invest money supposedly and create corporations which put people to work, and maybe that's for the better of mankind. And then there's the issue of speed. You know, by the time these guys put a corporation, we're all dead, and so maybe right now is the time to tax them, give the money to the poor somehow, you know, through some mechanism, fiscal or monetary, and have people be able to make it to the end of the month. So again, it's always that fight between conservatism and liberalism, Democrats, Republicans, communists, capitalism. You know, there's always that fight. Okay? It's been eternal. I don't think we'll ever eradicate in what little time remains here on Earth for us. Anyways, I always encourage people to do Extinction 101 before 102. 101 is mass extinction of past animals. 102 is human extinction. Before we can talk about human extinction, it's good to find out what happened to the animals in the past. Maybe the same thing's going to happen to us, and we can't do anything about it. Okay? And a good place to start is with what I call the homework, and that's the question is, why did the animals on land, that's really for Extinction 101, why did the animals on land die almost at the same time as the animals in the seas? Okay, and so yeah, that's where we stand on all that. Because if you can figure out why animals on land died more or less at the same time as animals in the seas, maybe you have the clue to how extinctions happened in the past, and maybe you can extrapolate those to man and figure out if we can do anything about that same process. Okay, so let's get on with the second part. Okay, give me a second here. And I'm going to deal with spin. Okay, and what is spin? Well, before we can get to spin, let me show you, start the talk with a song. Okay, it's the quantum song. Turns out one group figured it out and made a song dedicated to quantum mechanics. Okay, none of my friends, by the way. I wish they were. Okay, but here it is. It's the quantum song, I call it. And the guys call it superposition. We talked about that the other day. Superstition aims with imprecision. But when things can't be explained, superposition. Oh, I love that song. Yeah, my son pointed it out to me. I thought I'd bring it up, so go find it. It's called Superposition by Young the Giant group out there. And they say, but when things can't be explained, when the mathematician cannot explain to you, they just say superposition. More or less like Mary Poppins. You know, when she couldn't explain something, she would say supercalifragilisticexpialidocious. That's how it works. You know, when you don't know, just say, I don't know, say something like energy, and that'll fix all the problems. So what is this superposition? Well, I covered it the other day, okay? And it's, a horse stands still and it also runs at the same time. Okay, so, I don't know, maybe, maybe not, okay. Okay, so what is this spin thingy? Well, one of the visitors to the site here put this comment out there. He says, electrons do not spin, PBS space-time. okay? And I go in there, look at the video he referenced, and I had already the idea of doing spin today, so it just came in very handy, and it just coincidentally. And you go in there, and Matt O'Dowd, the guy who does the PBS physics, mathematics program, he says the following thing. It says, think of electrons as being connected to all other points in the universe by invisible strands. And you see it there, he illustrates, not this, but this. Huh? Let me read that again. Maybe I didn't read it properly. Maybe it went over my head. Let's see. Think of electrons as being connected to all other points in the universe by invisible strands. Okay? And the fellow makes the comment, says, it's staring them right in the dumb faces. Okay, so we're supposed to look at this as strands that somehow bind, interconnect. What did he say there? Connected to, right? So he's saying that, yeah, these strands are connected to every, I guess, atom in the universe, to all other electrons in the universe. That's what he wants you to think. Where did he get that? Okay? And here this is what he illustrates there. And so you ask, well, what are those ribbons? You know, I mean, where did he get that in quantum? Quantum was a particle theory. You know, you have these little dots, balls, corpuscles, grains of sand, grains of dust. And suddenly we have this interconnectivity. Suddenly, you know, all electrons are connected to all others, or to atoms, or to whatever matter is out there. He asks you to think of it that way because that's what they observe but don't observe. They can't see it, but this is the conclusion they arrive at by saying you're supposed to think of it that way. Okay. This is what you know, this fellow is not the only guy who said it. This is what I see out there. These are some of the statements, some of the testimonies you'll find out there in the same line. Here you have Michael Disney, and he says, but the electromagnetic theory is not based on action at a distance as was Newton's. Space is thought of as being threaded throughout with electrical and magnetic tensions. Dara Ebbing, he wrote an important book, General Chemistry. He says, a chemical bond acts like a stiff spring connecting nuclei. As a result, the nuclei in a molecule vibrate rather than maintaining fixed positions relative to each other. So the first guy says everything seems to be threaded throughout. The second guy says you got to think of it as stiff springs connecting nuclei. What did Matt O'Dowd say? All electrons are supposed to be thought of as being connected to something out there through some kind of ribbon, I guess. Here's the Casimir effect. A field in physics may be envisioned as if space were filled with interconnected vibrating balls and springs. And there was a conference at the University of Colorado known as Electromagnetic Waves, Physics 2000. It says, wiggling one charge causes the field lines attached to it to wiggle. And after a time, the other charge starts to wiggle. It's just like a rope connecting two rocks. The wave here consists of a wiggling line of electric force, which you can think of as being attached to the vibrating charge. Okay? So we seem to have not only one fella, but here we have at least several testimonies from professionals. People who supposedly are mathematical physicists if you want to call them, and these people are saying that everything is connected, but that's not quantum. But what quantum says. This is what quantum says. Okay. Well, this is our hydrogen atom. You can see it's connected to everything. You have the atom in the center. Okay, that's the center of the very center there. That's the conversion of all these threads. That's going to be the proton. That's the center of the hydrogen atom. And then the hydrogen atom has this shell, this membrane. Okay? this balloon that encapsulates the proton star, and that's going to be the electron shell, which pumps back and forth. That's the quantum jump, and by doing so, it torques the ropes. What ropes? All the ropes connected to it from every atom in the universe. So what these people are saying is that you have to think of it as this, but that's not what they illustrate. That's not what they believe in. That's what their mathematics addresses. What their mathematics addresses is something totally different. Okay? They talk about, individual particles. And so here's the difference between them and us. This is what quantum proposes. Discrete particles. We are the ones who are proposing that the atoms are interconnected. Where did quantum now come up with the idea that atoms are interconnected, and what is the physical entity that interconnects them? I mean, they have to identify them, but see, what they say is something different. They say you have to think of it as if. You're supposed to visualize it as if, but that's philosophy. That's not part of their physical interpretation. Physical interpretations is always particle moving through space, little ball moving through space. That's very different than saying that all these electrons, atoms, whatever, are connected, physically connected. Where is the connector? Where do we see that in the standard model? Okay, so it's cheating because they throw this out, but then they don't follow it. They don't say, well, we believe that everything's interconnected. They don't say that. They just say, you got to think of it as if. So it's the language that, is really killing them there. Okay, what does Matt continue? He says, quantum mechanics has lots of weird stuff, but there's one thing that everyone agrees that no one understands it. I'm talking about quantum spin. This elusive little behavior of the electron. Spin, well, spin there, you see it spinning. There's an electron spinning. It looks simple to me. I mean, why is this so mesmerizing for Mr. Dowd? You would think that he would understand spin just like I understand, or like anybody else understands spin. There you see it, right? But these people are saying that that's not spin. In other words, that's not at least how an electron spins, okay? So how does an electron spin, or what is a spin? And that's the question Matt asked. He said, what is spin? Well, you would think it's like that top there. We all understand spin. You just twirl a top and we understood spin. And Matt is saying, well, we're going to try to find out. He spends a whole show there trying to explain what spin is when it's very simple. There's a guy who also has like 6 videos, hour videos, like 6 hours talking about spin. I mean, spin is spin is spin. You take a top, you spin it, we know, right? Why is this so difficult? And so we have to look up what spin is, and we go to the Wikipedia. And here we find, which, a lot of these guys use anyways. Okay? And so what is spin? Well, here you see it. It says, spin, an intrinsic form of angular momentum. Carried by carried. They carry it on their back. The angular momentum. I like the words that mathematicians have to use, that have to invent the phrases they have to make in order to make their physical interpretations. So they carry the angular momentum, which is carried by elementary particles. Okay, I hope you understood. It carries it. Okay, composite particles, hadrons, and atomic nuclei. Okay, spin is one of 2 types of angular momentum in quantum mechanics. The other being orbital angular momentum. Orbital angular momentum, what is that? The quantum mechanical counterpart to the classical angular momentum of orbital revolution. Okay, there you see it. Okay, so in one case you see the electron orbiting the nucleus. In the other one you see you can say the skin of the electron orbiting its center. Okay, in other words, here is what we call spin, like the skin of the top rotates around its center, and that's going to be spin. And then the other one is called orbit, which is when you have 2 separate objects, okay, and one object goes around the other, like the Earth around the sun. Okay, straightforward, we understand that. Okay, so what's the problem? Why are these people having so much difficulty in in zeroing in on what spin is. Okay, and here's another continuation of that wiki article, and says the following. It says, for photons, spin is the quantum mechanical counterpart of polarization of light. Spin has no classical counterpart for electrons. Why not? I mean, spin is spin is spin is spin, right? The existence of electron spin angular momentum is inferred from experiments. And one of the prime experiments was the Stern-Gerlach experiment of 1922. They shot a bunch of silver atoms through a machine, and then had a magnetic field, an inhomogeneous magnetic field, which means that the particles are directed in one direction. There's more force on one side than on the other, so the particles are directed in one direction. Okay, they wanted to be able to control that. And it turns out that what they expected to see, according to classical mechanics, was a single line there. Okay, as you can see it, a distribution of all the atoms against the screen in a straight line. Instead, what they saw was two parts. One beam went up, the other beam went down. Okay, and so they related that to this property, intrinsic property of quantum mechanics that they say is called spin. So they never saw spin. Okay. They inferred spin, okay? That's important to note. No observation. They deduced it. They inferred it, okay? Okay, Nick Lucid, you know, Curdy, guy who has his own show, The Crazy Show there, whatever it's called. The Lunatic Science. Well, what does Nick say? Well, he says, he explains why, you know, the electron cannot have spin, okay, spinning like a top. Okay? If those electrons have a diameter of 10 to the negative 18 meters to be spinning with an angular momentum of 1/2 h bar, okay, the outer edge would be moving at almost 1,000,000 times the speed of light. So there you have this turtle of light, okay, and you can see the electron. I couldn't get it to spin 1,000,000 times faster, but it's moving faster than the turtle. That's the point, okay? So light would go slow, and the electron, the skin of the electron, right, would rotate faster than the speed of light. That's what he's saying. That's why they can't figure out what is really happening there, because, you know, the electron is a point particle, meaning it's even smaller than what he's saying there. It's like approaching zero, if not zero itself, because that's what a point particle is, just location and no body. And so he's saying that something so tiny would have to move so fast, much faster than the speed of light, that they cannot imagine the electron spinning like a top. Okay, I hope that sank in. Okay, that's what these people are saying. It spins, but it don't. Okay, so it spins, but it don't. Okay, so here we have another problem with spin, and that's that quantum top spins in both ways until you observe it. Remember, all properties like superposition and entanglement, it all has to do with the observer. And according to, you know, the catechism of quantum mechanics, once you observe something, once you touch it with your eyes or your hands, at that point the wave function collapses. And so before that, it's in both states. The cat is both dead or alive, and the top is spinning clockwise and counterclockwise. Maybe it's not spinning at all, okay, all at the same time, until you observe it, until you touch it, until you do something with it. Then the wave function collapses, and if it was going clockwise, counterclockwise, and standing still, suddenly it collapses, I don't know, to clockwise. And vice versa. It could collapse to counterclockwise, and so on down the line. So what we're talking about here is that it's got both or all properties simultaneously until you observe it, until you peek, until you touch it, until you detect it. With machine or with your eyesight, God doesn't want you to discover his secrets. That's what it's all about. And so they keep investigating, I don't know what, researching what, for the rest of humanity, for the rest of our existence, For what? If they already are telling you that they cannot peer into the invisible world of quantum mechanics, then what are they doing experiments for? To find more properties? What they need to do is stop doing experiments at some point and start explaining the experiments. And right now we don't have an explanation. What we have is descriptions, and the explanations are all irrational, and they say, well, yeah, it's the way it is. No, it's not the way it is. It's the way it is if you simulate everything with discrete particles. Then it's like that. Okay. Otherwise, no. Okay. So we need a new model. That's what it is. Okay. So what is spin? Well, I'm going to give you a shocker here. Okay. Spin is just a bunch of orientations. And one guy tried to illustrate that. You can see the electron going around the proton. And all they're looking at is, whenever they measure, they look at what direction that arrow is pointing to. Okay, and they say, okay, here the electron is pointing, I don't know, northwest, and over here it's pointing southeast, and so on. That's what they're looking at. So it's the orientation, the tilt, okay? That's what they're looking at. And they call that spin. And it gets even worse than that, because what they do next really blows anybody's mind. They go in there and they invented quantum numbers. Okay, here you see them. I like this one because the question of whether elementary particles actually rotate is ambiguous. No, it's not ambiguous. They're saying it doesn't. So it doesn't have that rotation like a top. So it's ambiguous. It's not. And then they say, why do they say that? It says, because they are like point-like particles. Yeah, if it's a point-like particles, meaning zero-dimensional, meaning no size, how can you conceptualize spin? And so what they've done is something even worse. They assign numbers to spin. You say, what do you mean you assign numbers to spin? What do numbers have to do with the physical spinning of a top? You spin a top, you give it, oh, that's half spin. I'll call that a 1 spin. I'll call that a 2 spin, a -1. What is this? You're going to put numbers to the spin of a top? What sense does that make? So spin has some peculiar properties, I guess, that distinguish it from orbital angular momentum. It says spin quantum numbers may take half integer values, like 0, half, 3 halves, 2, etc. And so there I show you two spins that I created. I guess the first one is a half spin because it rotated only half. The ball just went halfway. And the other one's a -4th spin because it went the other way, counterclockwise, and ended up there. I mean, you tell me, what do they mean by spin? So we have a lot of properties for this spin. It has several types of spin before you detect it. It's just orientation or tilt, and then it's got numbers assigned, I guess, to the different tilts. If it rotates only halfway, then it's a half spin. What is this? So it's got all these strange properties, and then of course a guy like Matt Dowd, supposedly a mathematical physicist, he comes out there and says, oh, by the way, we have no idea what spin is. Okay, but it turns out that they say they don't know what spin is, but they use the word spin. Why do they put the word spin? If they don't know what it is, they should have called it X, the property X. Then it would have been it would have been dubious. A lot of people would have thought, oh, okay, what does he really mean by X? But when they say spin, everybody says, oh, I know what that is. And even though they don't know what it is, that's how they use it. Here you have fellow James Lincoln, and he's from UCLA. He's got this video on the internet, YouTube, and says, how do magnets work? Okay, and he says, could it be that the electrons orbiting the iron atoms are the net cause of magnetism? That is, could it be that circling electrons are causing the magnetic field? In 1915, Albert Einstein von der Haas ran an experiment to check that it was the orbiting electrons that caused magnetism. The results were negative. In other words, it wasn't the angular momentum, the Earth going around the sun, that caused that caused attraction, that caused magnetism. But he continues, he says, later on, it was discovered that electrons had a property called spin. And there you can see him spinning the ball. Okay, what is he talking about? He's talking about spin. He's talking about top type of spin. That's what he illustrates. He says that is that the electron was spinning as it circled the nucleus. So what is he saying? He's saying the electron is spinning like you spin a top. He didn't qualify it in any way. Okay, so he's talking about spin like a top spin. There you see it again. See how he twirls the ball? And he says it's the alignment of these electron spin that results in the magnetic properties of iron. Okay, and he never goes beyond that. And he started saying he's going to tell you how magnets work. And that's all he says. That is the entire, I mean, you can just skip everything else because that's essentially what he ends up with. He says it's the alignment of these electron spins that results in the magnetic properties of iron. And so, I got a lot of questions there because I cannot imagine, the mechanism that he's trying to talk about. Okay, there you can see him spinning again. Okay. So I've got a problem because here I have two balls, okay? Okay, so this one's spinning. You can put them both clockwise, like he showed there. One clockwise, the other one counterclockwise. Do it any way you want. I don't care. Do it any way you want. How does this one attract that one? How does this ball attract this ball if there's nothing in between except what? We have to think of it as some interconnection there, elongated object. We got to think of it like that, but they don't illustrate it. They put the balls and they say this one affects that one. I want to know the mechanism. What is the mechanism? They say, well, you got to think of it as if. You see how they're doing it? So they're cheating because that's nowhere to be found in quantum. It's nowhere to be found in the standard model. Okay, but that's how they illustrate it. That's how they mimic it. Okay, and you say, okay, what is that ribbon, that thing that connects the two electrons or atoms or whatever? And that's where they say, well, you only have to think of it as if, and that's the end of it. There's no more than that. So yeah, the big problem of quantum mechanics is action at a distance, specifically the force of pull. How do you pull from a distance? How does this particle affect that particle from a distance without any physical mediator? The guy who does that is introducing spirits in that same space. There is no other way of looking at that. You're using black magic to get your theory across, your mechanism across. How does a rope model do it? Well, ours is simple, okay? How a magnet attracts another. You have the threads, and they do spin, okay? They spin clockwise or counterclockwise. And when they spin both clockwise, and then they're attracted. And when one of them is turned around, you'll see this in a second, we'll have repulsion. Why? Because you have blue against blue, meaning clockwise against counterclockwise. That's what happened. Now they push each other away. So it's very straightforward. You see the mechanism. You don't have to imagine it beyond what you see there. Okay? So if you want to know why two magnets attract and repel, there you have it. You have these threads that are swinging around that we cannot see or touch. Okay, so there's no purpose in running experiments. We have to explain how Mother Nature's doing this trick. Okay, that's all we have to do. And yeah, it's one of these things that we're not going to solve by going to the lab. Okay. Okay, so what are my conclusions about this so-called spin? Here they are. Okay. Spin is another mysterious property that quantum particles enjoy. Okay. Together with what? We had entanglement, we had superposition, decoherence, the cat, Schrodinger's cat, he's dead and alive. We have all these little properties, and this is just another one of those mysterious properties. Why is it mysterious? It's mysterious because they cannot explain action at a distance. You can't do that with particles, and that's what quantum is. Quantum means particle, means, it's a particle theory. You cannot explain this with discrete particles. That's what they have to abandon. But the mathematicians love particles because the particle is simply a location. It's an equation that puts a value there. And they can put that in an equation. If you put a ball, they can't put the ball in the equation. They have to put in a number. So they put the word energy, or they put mass or force or whatever, and they have values for this. They can play around with that in equations. And so now you're going to tell them after 100 years that there are no particles, no wave function collapses. Is that what you're going to tell them? No, of course, they're not going to buy it because it destroys their entire religion completely. And yeah, I'm saying religion, that's the correct word. Because it's a religion because all the explanations that they're giving you are irrational. And they believe in them. And they vouch for them. They say these theories, these mechanisms have been proven. And when you say, well, how do you prove something you cannot even imagine, which is irrational? They say, well, that's philosophy anyways. And that's it. And that's the end of the story for that. Okay, so mysterious. In this case, very mysterious because they cannot even describe spin. I mean, if they could at least describe what spin is, but they cannot. They cannot define or describe it. They cannot. Okay? And of course, then they cannot explain it. Why? Because it's an irrational mechanism. They're using black magic. They're saying that a zero-dimensional point particle has no body, no size, no diameter, no radius, no dimensions, is spinning. So what is it that is spinning? Please draw it for me so that I can visualize it. I cannot imagine a zero-dimensional nothing spinning. And that's what these people are saying. And then they assigned numbers to spin: half spin, 2 spin, 3 half spin, and so on. Negative spin goes in the opposite direction, I guess. Not direction because it's not spinning, so I don't know what negative spin means. I mean, negative half spin, what can that possibly mean? It just means it's got oriented in the other direction. It was clockwise spinning, counterclockwise. I don't know. You figure it out. I can't help you there. Particle spins in both ways until you observe it. That's the wave function collapse. At that point, all properties condense to one series of properties. Okay, but a quantum particle has no size, so what is spinning? But let's use the common notion of spin that everybody has when explaining. So you're going to use it anyways as spin, and they're going to use that word spin because everybody understands the word spin. They think they know what the mathematician is talking about, and you just saw James Lincoln there saying, yeah, it's spin. And he still, even with his little spin, which is not spin in quantum mechanics, he cannot explain attraction. He just says it is so. When they're spinning in the same direction, the magnets attract. Okay, so how does the electron over here spinning have any effect on the electron spinning here? And that's when they turn the lines of force, magnetic lines of force, which they say do not exist, are not real, that they're put in there just to explain something, but that they don't exist. So they're saying this ball affects that ball from a distance by what? By black magic. So yeah, it's a big problem. And magnetic attraction because the electrons of the atoms on each magnet spin. So that still doesn't explain action at a distance. And so the question is, so what is the mechanism? What is the mechanism not only of magnetic attraction, what is the mechanism of spin? We still don't know what spin is, but everybody knows because everybody simulates it the same way by twirling a top and saying that's spin. You figure it out. Okay, let's get on with the questions and comments that people made. Here we have a fellow, he says, the part I didn't understand is why a phase difference rotation, he's talking about polarization here, should have any influence on brightness at all. As I understand it, an atom is lit when it is pumping. A rope twists down its length to an atom and this squeezes or stretches it. I don't know what this fellow understood. Putting it under stress, causing it to relax and untwist back in the opposite direction on the same rope. Well, I can't vouch because I don't know what this guy is talking about. He's probably went to some other site and got this information from over there. The funny part about this is not this what he's saying there that he doesn't understand. The question is that, you know, when you look at interference, which is essentially what he's talking about here, diffraction, I said polarization, it was diffraction. you know, you get the typical diffraction pattern where you have two waves which are in phase and two waves which are out of phase. And when they're in phase, it produces constructive interference. And when they're out of phase, it produces destructive interference. And this is what you'll see out there, okay? This is how it's illustrated, okay? You can see there constructive and destructive interference, but they do it with waves. There is no such thing as a wave in physics. There's no physical object called wave. Wave is a verb. And so these people are putting a little wiggly thing there, and you say, what is that wiggly? Is that a string? Is that a thread that you're moving up and down? What is that? And they illustrate it, but they never tell you what it is, because there is no such thing as a wave. They call that a wave. Well, what is it? Is it a string, a thread, a wire? What is that? Curlicue? And so, you know, they don't tell you what it is. They say it's a wave, but the point here is that nobody asks the question. Says, okay, I understand that. When they're out of phase, it's destructive interference. When they're in phase, it's constructive interference. We're done. And everybody walks away. Nobody asks any questions. And here I'm showing the same thing. I put an object there. I put the rope, which I've illustrated already several times. And this guy says, I don't understand. Well, try to understand the wave first, okay? When you can explain the wave interference to me, then I'll explain the rope to you, because you'll go on a faster learning curve if you can explain that, okay? Because this has been around for at least 100 years, I'd say, wave interference, okay? And so if you understand that, you should be able to understand the rope model, because the rope model is the same thing, except we do it with a rope. Now, was that difficult or what? Okay. So yeah, some people, I don't know, they have to start with quantum first. Once you understand quantum, especially regarding interference, you should have no trouble with a rope model. Okay. So I really don't know what the stumbling block is there. Okay, another fellow says, please, can you give your opinion on mass physics being an extension of hypothetical geometry under a different name? I have no idea what this guy is talking about. I have no clue, but thank you for your visit. Okay, no idea what he means by that. Okay, another fellow says along the same line, math is reality. Nature deals with numbers and equations. Absolutely not. Mother Nature never went to school. She never learned math. Okay, Mother Nature just deals with objects. Physics is reality. Math is something invented by man to try to figure out, to try to describe nature. Okay, and they did a good job with the visible and tangible things, but they did a very lousy job with the invisible, intangible things. Okay, so no, Mother Nature does not know math, okay, at all. Math has no place in science. Math is just a language. It's a language that can only describe. It's a language of quantitative adverbs only. Math has nothing other than quantitative adverbs. Okay, no adjectives. Adjectives qualify objects. Okay, red, blue, that kind of stuff. Yeah, you can put frequency or wavelength and apply a number to that. But Mother Nature works with the object that is mediating light, not with a number. She doesn't know anything about numbers. Okay, we are the people who invented numbers and try to, apply them to Mother Nature's objective world. And if you go to another planet, to the planet of the Klingons, I'm sure they have different standards. I'm sure they don't have the meter, they don't have the kilometer, they don't have the mile, they don't have the kilogram, the second. I'm sure they have different quantities, okay, or units. Okay, another fellow says the following. He says, the person said thoughts and emotions affect plants, and I agree, but I have a mechanism. Okay, every atom in my brain is connected to every atom in the universe. Yeah, okay, that's the rope model. When I change the electrical nature of my brain, my thinking in certain ways, it changes the frequency of the ropes. Yes, using the ropes, I can communicate with plants and water. I don't challenge any of that. Okay, I'm saying that we're connected. Every atom in our body is connected to every atom in the universe, let alone to every atom in the room, every atom of your girlfriend or whatever. We're all interconnected right through the center of the earth. Okay, and so no problem there. It doesn't mean that you can move things around. I cannot, because I'm in touch with a pencil, doesn't mean that by thinking I'm going to move the pencil around, because that requires a different physics. The question is whether by thinking I can affect a plant growth or whatever, or whether I can affect a boiling water or whatever, okay, water in any way. That's not the issue. In other words, it could be and it could be not. I don't know if it's the case or not, and I'm not even worried about these things, whether, with my thinking I can affect the plant growth or water. I'm not worried about that at all. Okay, this is what I'm worried about. Okay, and which is what I mentioned the other day with the fellow who put that comment, the comment that this fellow is addressing, right? And it says, do you think your emotions and thoughts are physical mechanisms? What makes you think it has to be a physical mechanism that drives the universe? This is what this fellow put the other day. And so I put in there and read there, otherwise he's using black magic if there is no physical mechanism. Okay, so the guy thinks that everything is done by black magic, that there is no interconnectivity, that there is no physical mechanism that underlies phenomena out there, especially the mediators that we cannot see for light, for gravity, for magnetism. So he thinks that there is no physical mechanism. So essentially he believes in black magic. He's saying we don't have a mechanism. Mechanism meaning objects. You need objects to mediate things. And this fellow is saying that we can do it without mediators. Yeah, it's known as black magic. And so the pen falls to the floor, no physical mechanism. By what mechanism do you propose emotions and thought affect plants and waters from a distance? Assuming they do. Okay, we're not going to worry about whether they do or not. We'll just concede. Let's assume that mind affects plants, mind affects water from a distance. By what mechanism? What are we going to put between the brain and the plant? What are we going to put between the brain and water? And if the guy says absolutely nothing, then he is doing black magic. He's saying that Mother Nature does things by magic. Okay? So this is the issue. The issue is that this fellow has to address why, what causes, what mechanism, what entity is there that we cannot see or touch. Otherwise, he's got nothing. And yeah, religious people like him believe in all this stuff, and this is the issue. That they believe that all this is done by math. They use words of incantation such as energy, force, field, wave, and those are not physical objects. Okay, there is no physical object called field. There's no physical object called energy. Those are mathematical concepts. That's why energy has units. And when used by mathematicians, they always put a value followed by units. Could be ergs or whatever, But yeah, they're mathematical concepts. There is no physical standalone object called energy. But they use it as such, and we got so used to it in the everyday talk out there that people think that whenever someone says energy, oh, I transferred energy, oh, did you pay your energy bill? So people think that you receive something like, I received energy in my house. No, energy is a short hand for something that happened. Okay, you got to tell me what that something that did something is. Otherwise, you can't say, oh, energy did it, or field, or whatever, wave. None of those words qualify as physical objects. That's why we needed to define what an object is for the purposes of physics. And it is that which has shape. The only universal property of objects. All objects, hopefully, have shape. And if you believe otherwise, please, next time you put a comment, put down the object that you think does not have shape. I want to see one object in the universe, anywhere, that doesn't have shape. Okay. Fellow said, oh, this was the answer that this guy gave the first guy. Okay. The first guy was answered by a second guy, and now the first guy came back and answers the second guy again. It says, there is an electromagnetic field we can measure that is produced by our body. What is field? A physical quantity. Okay, so field cannot do anything. There is a singularity with one side of it acting like a multiple Klein bottle on steroids. Okay, I don't know what this guy's on, but singularity, a point at which a given mathematical object is not defined. So we can't use the singularity as anything. It's not a physical object, it's not a thing, it's a concept, and an irrational concept. Okay, and then a holographic fractal with one center is the nature of connectedness. What's a fractal? A subset of Euclidean space with a fractal dimension that strictly exceeds its topological dimension. Yeah, fractal is a mathematical concept, has nothing to do with physics, so you cannot say that a fractal has anything to do with connectedness. Okay? It's not a physical entity, and what all these people are using is words of ordinary speech, or the notion of ordinary speech, and bringing it into science. These mathematicians, they discovered the word energy. So they put numbers in it, they put units. The general public listens to the word energy, they start using it. Oh, I did energy this, I pushed energy over there, I hit the ball 10 times and it had a lot of energy, and we treat it like a physical object. Then we go back and get that word energy from the vernacular, from the ordinary speech, and bring it back into science. And then we start talking about energy as if it were something, as if you can transfer and kick it and lift it and do anything you want with it, and convert it into mass and so on, another concept. So yeah, it's the language that's killing all these people. Okay? They confuse ordinary speech with science first, and second, none of these terms have ever been defined scientifically, and they're all concepts. None of them are objects, and for that we had to define the word object for the purposes of physics, because these people are treating all concepts as physical objects. Okay, another comment, another question. The fellow says, rope models should be complementary to the electric universe and vice versa. Absolutely not. Electric universe has no clue about anything whatsoever. And the reason they don't have any clue is that, again, they don't know what, first of all, the main word in their title, electricity. They don't know what electricity is. They even tell you that they have no definition for the word electricity. They have no idea what electricity is. And they form this electric universe. And it's completely different than the rope model, because the rope model talks about interconnectivity, the entire universe being physically interconnected. All atoms are connected to all others. That's not what the electric universe proposes. Electric universe uses the quantum atom. You know, the little ball, hydrogen, right? Using that as a model. Little ball with the electrons spinning around. They don't know why that electron spins around, why it doesn't fly away. And with that, two discrete balls, how do you produce interconnectivity across the universe? You know, the so-called filaments that these people talk about. How do you produce them with electricity when they don't know what electricity is? They think electricity is what quantum told them, which is the flow of electron beads. How do you produce connectivity, interconnectivity in the universe at any scale that you want with discrete balls, which is what the electric universe uses? So no, the electric universe not only is unscientific because it hasn't defined a single word necessary to do physics, which are object, exist, location, motion. They haven't defined these words. So they're in the same boat as the mathematical physics. There's no difference between them as far as we're concerned. So don't never mix electric universe with us. Please. Don't insult us. I'd rather you cuss my mother and not tell me that electric universe is like rope model. Okay, how many of these physicists believe that a pregnant woman's fetus is neither male nor female and thus in a quantum state until being born and gender detected via ultrasound? Yeah, I like that one. Good. 10 points for that guy. I owe this guy a beer. But he's got a second one I like as much. Very good. says, bank informs physicists, sir, we did not know the status of your saving account until we looked. Either it contained the 20,000 as you said it did, or it did not. I am now informing you that once we looked, we found that the account was completely empty. Very, very good. I love them. Thank you. Yeah, the quantum, what is this? It says that the wave function collapses. Does your account collapse when the banker looks at it? Collapses to zero or maybe to 1 penny? He says that's all your quantum money collapsed to. Okay, another fellow, or a couple of fellows really pointed me to a video. How big is a visible photon? Have you seen this explanation? Yeah, I went in there and looked at that video. And this is what this fellow says over there at that video. Okay. And what he illustrates also says the field is the sum of many photons. Okay. So is that what a photon looks like? Like many photons making up the field? Then he continues, says we have two continuous coherent beams interfering. Beams interfere. Beam is a concept. What is the beam? What is mediating the so-called beam? This is a very counterintuitive if you are taught that light is quantized. No kidding. Yeah, it's irrational, not counterintuitive. It's known as irrational. If you are taught that light is quantized, it makes no sense to make it continuous. Either this thing we call light is continuous or it's quantized, meaning it's made of little pieces. Can't be both ways. Some people have proposed chains, links on chains. Others have proposed, ribbons. I've heard several substitutions for my rope out there. And yeah, the problem is as soon as you quantize it, because they're trying to explain how one rope goes through another, and they think they're going to do it by quantizing it, by turning it back into particles of some kind, ring shape or whatever. No, you don't do that. We can't. Okay. It's a long story, but yeah, at least it's against the rope model. And the fellow says, we are not observing single photons. Yeah, no kidding. And so he goes in there and puts this up. There's another one here. If I can find it. Oh, here it is. The fellow says the following. Says, when we can never observe interference from just a single photon. Hey, yeah, of course you can. Because a single photon cannot interface with itself. What sense does that make to say that a ball interacts with itself or interferes with itself? Because demonstrating interference always involves collecting many photon detection events. The field is also not quantized. Yeah, so again, this is nothing new, what this fellow is pointing out. He hasn't figured out anything. Okay? He hasn't figured out anything because, again, all these people, what they do is experiments. They do experiments, and they think they're going to figure out the invisible, intangible world through experiments. So what is the purpose of an experiment if you can't see or touch the mediators that Mother Nature uses? And so what they did, they introduced zero-dimensional particles, point particles. They introduced waves, wave packets. They put all this nonsense out there, and none of them can simulate what Mother Nature does. Okay, you need a physical object. For that, you need to know what an object is. What is an object? It's not which you can touch or that which you can see. It's that which has shape. Once you get over that, then you know that you're not supposed to touch the rope that is going to do gravity, light, magnetism, and all these other phenomena, electricity, and so on. You can't see or touch. You have to imagine it, and for that, all you need is a shape. Okay, final issue. Fellow says, why do you reject the object status of shadows for non-standalone shape when the rope atoms shape are just as non-standalone? Okay, what is he referring to? He's referring to this, okay, which I showed earlier. Okay, and that's that, the atom is just that ball in the center. All the others are ropes converging upon it from other atoms. So what does that mean? Well, it means that an atom is not cut at the surface of the electron shell because all the ropes continue onto other atoms, individual ropes that continue. So that's what he's challenging. Okay, let me put this over here. So he continues. He says, I argue not in favor of shadows as objects, but against atoms, tables, trees, humans being objects. Okay, well, you need to define the word object for us to follow what you're saying. Otherwise, the mind may divide the thread into more and more objects. Sounds like Fractal Woman, a lady who does fancy stuff out there, counter space. What's the difference? Well, the first thing you need to define the word object, okay? We define it as shape. Does the atom have shape? Well, for all practical purposes, everyday stuff, we say that an atom stops at the electron shell, and the table stops where the table has its edge, because we can't see anything or touch anything between the table and the chair. So we stop it there. Does the table continue? Is it a discrete object? No, because all ropes from every atom from the table is extending to every atom in the universe. So the table doesn't stop at the limit that we can see or touch. So the issue here is that the table has shape as it is without the ropes. Okay, but why do we put the ropes? Well, we put the ropes because that's what Mother Nature sees, not what we see or touch. Okay, but what is different? What is different between this and a shadow? Well, a shadow does require two objects. You cannot have a shadow without the light pointed at an object. So the shadow is a consequence of light. It's a process. It's a phenomenon, not a thing. Okay, shadow is simply an extrapolation of light with something in between. The word shadow means blocked light. And that's very different than what we're saying here. We're saying that an atom is a physical object. Why? Because we say it stops at the electron shell. Is it because, if it continues, is it an object? Well, for the purposes of physics, we consider it an object and we stop it there because that's what we can usually see or touch. But we have to be conscious that the object does not stop there. It's for Mother Nature, for her. It's not an object. The only object that really exists is the thread, the single thread. That's the only object that truly meets the definition of the word object, which is shape. All others, we have to imagine them as radiations of gazillions of ropes that extend from the table, from the chair, from the tree, from the rock. Okay, you can't cut the ropes. Okay, the ropes are there. You just can't see them or touch them. Okay, and so we say shape. Why? Because that's the word we can relate all objects with, that we can use consistently in ordinary physics, in everyday physics. Yes, if you go to little details, you're just going to say the atom doesn't stop at the shell. Yeah, correct. We know that. Okay, we're aware of that. But the issue here is that we have to do physics, and for that we have to define the word object, because we can't do physics without objects. So we need a definition for the word object, and that's what we don't have today. What we have today is the see-touch, and that is not a good definition because not all objects can be seen or touched, specifically the rope, all the ropes that converge upon an atom. With that, I'll see you on Sunday, and yeah, we'll see you then. Bye-bye.